All right, review 6, going to roll through these for you. Segment CD, number 1, segment CD is the perpendicular bisector of AB at E. Which one of the following pairs of segments does not have to be congruent? So what we're going to do is we're going to draw this out here. All right, so CD is the perpendicular bisector of AB at E. All right, so we have AB. We have AB. And CD is the bisector, the perpendicular bisector. So CD is the perpendicular bisector at E. So this is E right here. This middle point is E. All right, now, because it's a perpendicular bisector, here's what we know. We know this piece is congruent to this piece. We know we have right angles here. Okay, but that's not even what we're talking about. And if you connect A to D, that's got to be the same as D to B. Okay, those got to be congruent. And then if you connect A to C, that's got to be the same as C to B. Those have to be congruent. So AE and EB are congruent, AC and CB are congruent, AD and DB are congruent. So which one is not true? It is D. DE and CE. Okay, DE and CE do not have to be congruent because CD was not bisected. AB was bisected. CD was not bisected. All right, so that is the one that would not necessarily, it says which one does not have to be congruent. That would be the one there. For number 2, if triangle A prime, B prime, C prime is the image of ABC, under which transformation will the triangles not be congruent? Well, the only way you don't get a congruent, you might get similar but not congruent, is for a dilation. So a dilation is centered at the origin with scale factor 2. That's going to be the one that would be not congruent. Anything with a dilation is not congruent necessarily, or it can't be. Number 3, a line that passes through the points whose coordinates are 1, 1 and 5, 7 is dilated by a scale factor of 3 and centered at the origin. The image of the line is what? Well, whenever you do a dilation, you're going to get parallel line segments. So if you say you have this segment right here, if you dilate it, it's just going to do something like this. Regardless, it doesn't matter. I don't even need to graph this. I already know that a dilation is going to keep parallelism. So a dilation always keeps lines parallel or line segments parallel. All right, so I always know the answer is parallel when they're talking about the dilation. Number 4, if triangle ABC is dilated by a scale factor of 3, which statement is true of the image of triangle A prime, B prime, C prime? When you dilate by 3, the angles stay the same. So this one's saying 3 times the angle. That would not be it. So that's not true. The angle does not multiply by 3. It's this one right here is the answer. B prime C prime equals 3 times BC. Because that's what happens. When you dilate by 3, the length of each side is 3 times as long. So if this is the original BC, then when I dilate by 3, the new one's going to be 3 times as long. And that's what that's saying right there. B prime C prime equals 3 times BC. An equilateral triangle has sides of length 20 to the nearest tenth. What is the height of the equilateral triangle? So I'm going to draw this out here. I'm just going to use this space. I'm going to use this space right here for 5, and then I'll go to 6. I'll do 6 over here. All right. So for 5, I have an equilateral triangle, and all the sides are 20. What is the length of the equilateral, what is the height? No, the height would be this guy right here. So this is 10 and 10. Now the height makes a right angle. Okay, so I have a right triangle here, 20 and 10, and I'm trying to find the height. Well, the height is one side of a right triangle. Remember, when I have a right triangle, I can use the Pythagorean theorem if I know 2 sides. 20 is going to be the hypotenuse. So I'm going to do 10 squared plus x squared equals 20 squared. I'll do the Pythagorean theorem on this right triangle, or you could do this side over here, doesn't matter, same thing. This is going to be 100 plus x squared equals 400, and that's going to be x squared. I just got to extend the page a little bit. All right, this is going to be x squared equals, when I subtract 100 to the other side, it'd be 300, and then take the square root. The square root of 300 is going to give us 17.3. Okay, when you throw that in your calculator. All right, number 6, the ratio of similarity of triangle boy to triangle girl is 1 to 2. If BO is x plus 3 and GR is 3x minus 1, find the length of GR. So again, BOY to GRL is 1 to 2. So it's a 1 to 2 ratio when I do BOY to GRL. So anything when you're comparing BOY to GRL, as long as you're comparing corresponding sides, I can do a proportion of 1 to 2. BO and GR are the first 2 letters. See that? So I could say 1 to 2 BO to GR. That is a proportion I can write. BO is x plus 3, so now I'm just substituting. X plus 3 over 3x minus 1. And then I cross multiply. Now keep these in parentheses because you're going to make sure you distribute the 2. That 2 has to multiply to both of those. So it's going to be 2x plus 6 equals 3x minus 1. Subtract 2x, add 1, you're going to get 7 equals x. 7 equals x, and they want the length of GR. So that's not my final answer. X is 7. GR is 3x minus 1. So 3 times 7 minus 1, which is 20. So 20 would be my final answer there. GR was 3x minus 1, x was 7. Plug in the 7, you get 20. All right. In the diagram below, these are similar triangles. Which measurements are justified by this similarity? It's going to be choice A. I did this ahead of time to save time. AD is 2, and you just have to test these out. AB is 6. AE is 5. And AC is 15. Now, how do I know that works? You just do a proportion. 2 is to 6 as 5 is to 15. And does that work? Yes, this is 1/3, and this is 1/3. So you got to make sure the sides are proportional, and if they are, it justifies the similarity. If you do the other ones, it does not work. Okay? So you got to pick the ones where the sides are proportional. Make sure they equal. In the diagram of parallelogram FRED shown below, ED is extended to A, AF is drawn such that AF is congruent to DF. So I'm going to put AF congruent to DF. Angle R is 124. They want us to find AFD. AFD, they want us to find this angle up here. I'm just going to color it in. We're finding that angle there. Okay, so parallelogram, opposite angles are equal. So this is 124. Okay, and then you have the 180 right here. See that? So this angle D right there is 180 minus 124. 180 minus 124, and that's going to be 56. So if that's 56, so I'm not just going to get rid of this here. I'm going to write a little smaller. All right, so this is 56, and that means this is 56 because it's an isosceles triangle. When you have 2 equal sides, you have 2 equal angles. We know that. Those are both 56, and then the 3 angles of the triangle have to add up to 180. 56 and 56 is 112, and then 180 minus 112 gives us 68. Okay, so angle F, that angle there must be 68, and that was the one we were looking for. So you got to use a combination of things sometimes. In triangle CHR, O is on HR, D is on CR, and angle H is congruent to RDO. Angle H is congruent to RDO. All right, if RD, now what we have to do here is we have to draw these triangles separately. So here's the big one. HCR, and we know angle H. And now I'm going to draw, and I'm going to flip this one around just to make it look the same. I'm going to do it over here. Kind of look the same. D corresponds to H, right? H and D are congruent, so D corresponds to H. And then I have I have R, and then I have O. I'm putting the R there because angle R is a shared angle. Now, if angle R is a shared angle, I know angle R corresponds to R. So, now I know my corresponding pieces. I know D corresponds to H, R corresponds to R, and O corresponds to C. So RD is 4, so that's 4. It's going to make it easier to write a proportion. RO is 6, RO is 6, RO is 6. OH is 4, OH is 4. I don't have OH, but I have HR. See, now that I put it here, 4 and 6 is 10. So HR is 10. All right, so now I have OR, I have DR, I have HR. I'm trying to find CD. Okay, I'm trying to find CD, which is here to here. CD. All right, oop, I didn't mean to put a D there. This is D right here. All right, now I know DR is 4. So if I could find CR, that's what we're going to call X, and then we'll find CD after. So let's do that. We have a proportion. We have 4 is to 10. 4 is to 10 as 6 is to X. 4x equals 60. X is 15. I think we know that. That's easy right now, right? X is 15. X is 15, but CD is only part of the whole. So the whole thing's 15. This piece is already 4, so CD must be 11. 11 and 4 makes up that 15. So CD is 11. That would be our final answer. CD equals 11. All right, so we had a lot going on there. These last 3 pages, there's only a couple on each page. In number 10, we have similar triangles, right? Well, it doesn't say similar, but it says a clockwise rotation of 180. You need to know that a rotation keeps, there's a rotation, obviously there's a dilation as well, right? A rotation and a dilation. When you do a rotation and a dilation, the sides are proportional, all right? So we're going to make sure we know that we have these proportions work. So which one is it? Angle B corresponds to E, okay, and C corresponds to F when you rotate. All right, so angle B to angle E must equal C to F because B and B and E are actually congruent angles and C and F are congruent angles. So they must be in proportion. So the angles are in proportion as well. In the diagram below, we have, looks like we have a dilation, right? So describe the transformation that was performed. It looks like there was a dilation, and so we'll say dilation, and we're going to be more specific, D, and now what happened? Okay, so it looks like the length, well, if you do the lengths, you'll be able to know for sure. If you count A prime to B prime, this is 20. And this is, no, 16. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, this is 20. And this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 8, and this is 20. So what happened is it did 20 over 8, which is a ratio of 5 to 2. Okay, so as long as you could tell the comparison of the two, all right, it's a 5 to 2 dilation. So it's and that's about the origin, all right? So we can say origin 5, 2. All right, so dilation about the origin of 5 halves. And again, I just counted those. You could have counted B to C, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6. 15 to 6 is also 5 to 2. All right, so that reduces to a 5 to 2 ratio. All right, once you get that, that'll be the scale factor of the dilation. Explain why they are similar. Okay, sides are proportional. Sides are proportional. Therefore, similar. Therefore, triangles are similar. You also could say that all dilations, when dilations occur, the triangles, the image and the preimage are similar. Okay, for all dilations, the image and the pre-image are similar if you're doing a dilation. All right, 12. CF is 24. We haven't done this in a while. CF, now these are medians, okay? So that means G is the centroid. G is the centroid. So we're doing the centroid theorem. Look that up in your notes. Centroid theorem. CF is 24. That's the whole thing. This whole piece right here is 24. So we have, I'm just going to pull that out here. We have CF. We know the whole thing is 24. And we know that the bigger piece is 2 times the smaller piece when we're doing the centroid theorem, when we have a centroid. So this is 2x and this is x. So x plus 2x equals 24. 3x equals 24. X equals 8. So I know that the smaller piece is 8, and I know that the larger piece is 16. 16 is double 8, right? 16 is double 8, and 8 and 16 add up to 24. So I know that they want FG. FG was the smaller piece, so FG is 8. So 8 would be my answer for this one here because they wanted the smaller piece. In the diagram below, A is the midpoint of UV. So this is a midpoint. B is the midpoint. C is the midpoint. So we are doing the mid-segment theorem. Okay. This mid-segment AB is half of the parallel side. Okay. AB is half of the parallel side. So what we're going to do is double the mid-segment. I'm going to do 2 times 3x plus 1. Double the smaller piece, and you'll get the larger piece, 7x minus 3. Or you could just do, okay, what's 2 times 3x plus 1? 6x plus 2. Double the midsegment, and you will get the base. And then you're just solving 5 equals x. Okay, 5 equals x. And they want VC. Now, VC is half of the whole thing. So VC will actually be the same as AB. VC will be the same as AB. So 3 times 5 plus 1, that'll be 16. So my final answer is 16. The mid-segment's 16, so this is going to be 16. The whole thing will be 32. It'll be 16 for the small one, 32 for the full thing, but we just want VC, which is half. So we just want the 16. That'll be our final answer there. All right, in the diagram, find the perimeter of the triangle formed by connecting the midpoints. Well, here's the midpoint, here's the midpoint, here's the midpoint. All right, so if we connect the midpoints, I get 3 mid-segments. Each mid-segment is parallel to a side, and it's half of that side. So if this is 16, this is 8. If this is 14, this is 7. If this is 10, this is 5. Get it? Okay, half of the parallel side. Now I want the perimeter of that triangle, the triangle formed. 8 plus 7 plus 5 is going to be 20. So the perimeter of the triangle formed is going to be 20. 15 needed to be done with a compass. If you don't have a compass, just kind of pay attention here. Here's the center of dilation D. So you connect DB, DC, DA. And you just draw a dotted line going through it. We did this in the one lesson where we did dilations, okay? Connect through, connect through, connect through. That's just going to expand that triangle as big as we want. Because we're doing a scale factor of 2, all we got to do is copy the distance and do it one more time. So if I get my compass to go DB, then put my compass on B and copy that distance. Put your compass on DA, right? And then copy that distance, whatever that distance is. So it'll be up there somewhere. Then go DC and copy that distance somewhere right about there. I just estimated it. I freehanded it. So you should have gotten 3 points. One here, and one here. And that's going to be, this will be A prime, and this will be B prime, and this will be C prime. Again, you just copy the distance one more time, because if you do it one more time, it's going to double it. And then you connect with a straight edge Always with a straight edge. If you're at home, you don't have a straight edge, you could just fold a piece of paper in half and use that. All right, but I don't want to see freehand when you hand this in tomorrow. Everything should be straight edge, and there we go. We doubled the length of all the sides of the triangle. Describe the relationship between AC and AC prime. A prime, C prime is double AC. Okay, double the length of AC. And a couple more here. So for this one, they're drawn to scale. RS is 6. All right, ST is 14. XY is 9. And YZ is 21. All right, it looks like we have similar triangle. Or they're asking you if they're similar. Well, they'll be similar if the sides are proportional. Okay, so we got to see what's going on here. S and Y correspond. I'm going by the middle letter. S and Y are corresponding. So then these sides have to correspond. So 14 to 21 as 6 is to 9. Is that true? Well, this is 1/2. Okay, and let's see, 6 went to 9. And 14 went to 21. No, that's not 1/2. What am I doing? 14 to 21 is 2/3. And 6 to 9 is 2/3. Okay. Now, angle S is congruent to angle Y. So, because I have sides proportional and I have congruent angles in between them, I have yes, similar by side, angle, side, similarity. And this kind of shows the proportional sides, and then angle S congruent to angle Y shows that you have the congruent angle that you need. We're going to, on this one here, I actually was going to have you skip this one. So if you couldn't do this one, that's my fault. I should have told you in class to skip this one. So we are actually omitting number 17 because we didn't do coordinates yet with the dilations, to where we didn't do this type of question yet. We're going to do it later on in the year when we do, because you're going to need slope for this. All right, and this one here, AB is parallel to DE. All right, so they are parallel, and they want us to prove similar triangles. All right, so this is going to be pretty easy here. Statements. Similarity proofs are really easy, guys. Just do a little bit of thinking and I think you'll get it. So we're given parallel, and you're not going to have to do anything really crazy on the quiz tomorrow. It'll be a nice, easy proof for you. All right. This is given. All right. Now, there's a couple ways to do this one. You only need angle, angle. If you have parallel lines, you have a transversal. All right. Angle B would be congruent to angle E. And also angle A would be congruent to angle D. And that's because of the alternate interior angles theorem. Okay, if you have parallel lines then cut by a transversal, then the alternate interior angles are congruent. All right, so then once you have that, you would say triangle ABC is similar to triangle DEC, and that is because of angle similarity. Okay, now if you did vertical angles, that's also okay, but that would give you a third pair of angles. You didn't need that. All right, you only need 2 pairs of angles, 2 pairs of corresponding angles, and then you have similar triangles. So once you get that, you are done, and that was a nice simple proof there for our review. I will see you in class for the quiz tomorrow. Please make sure you go over this and understand what's going on in this video here. See you then.